Good morning to everyone present here. I'm Sangeeta Lakshmi, working as Assistant Professor in ECE Department at R.M.K College of Engineering and Technology. Today we are going to discuss about the Unit 3, that is Sequential Circuit Design, Session 1. First of all, we have to know what is sequential circuits. See, sequential circuit means it is a combination of combinational circuit plus memory element, right? See here, Here I'm having the combinational circuit plus memory element like register or flip-flop. It becomes the sequential circuit. See, always the combinational circuit means it depends upon only the present input, right? The output is mainly depends upon the present input. But in sequential logic design means the output of the sequential logic is depends on present input as well as the present state, right? So if you want to store the present state, we need some memory elements. So these memory elements are also called as storage elements. Why means it is not only used to store the data, it is also used to sequence the operation. That's why the memory elements such as latches, flip-flops are also called as sequencing element. Okay. See how the sequential circuit or register will store the data means they are using the two mechanism. One is positive feedback, another one is charge base. That is, if we are using the memory elements with positive feedback, then it is called as static register or static latches. Okay. Suppose if the circuit or resistor which uses the capacitor associated with the mass transistors to store the data means it is called dynamic. So the main difference between dynamic as well as the static is in static it uses a positive feedback, whereas in dynamic it uses the capacitors to store the data. And one more thing is the dynamic latches and memory can store the data only for um, a small interval of time. That is because it uses the capacitance to store the data. So it can store the data only for some particular time. See, after that it requires the refreshment. Whereas in static it uses a positive feedback. So it can hold the value as long as the power is on. Okay. So that is the main difference between static and dynamic. Next, we are going to see the difference between latches as well as registers. See, the latches mean it can sample the data as long as my clock is 0 or clock is 1. See here taking the clock is low. That is when my clock is 1, that time my output Q equal to D means that is called as positive latch. Whereas when my clock is 0, that time my output equal to input means that is called negative latch, right? So here you can see here, this is my clock signal, right? It is 0, it is 1, like that, it is keep on changing. This is my input data, right? This is my input data, this is my output of the latch. See, at this clock, during the clock is high, whatever changes, it is copied at the output side. Okay, during negative, you can see here during negative, it is um, it is just last value. Here we have the 1, right? The same one we retain up to the full clock period. Even though it is changes, won't copy. Whatever data here we are having, the same will be replicated here. Again, it will see when the clock is raises from 0 to 1. So as long as my clock is 1, that time my what is my data here is, it is up to here only we have the 1 data. So it is copied the same here also, right? And here it is changes from 1 to 0. So that is also copied here. But after that, during negative period, what I am having here, the same will be copied up to the next clock cycle. Okay. So this is called positive latch. Negative latch means as long as my clock is 0, whatever changes in the input, that same is copied at the output side, right? And register means it is the two latches if you are connected, it will become register. Okay. See, whenever the transition from 0 to 1, this transition, what is my input data, right? That data only copied at the output side, and this data will be maintained up to full clock period, right? Next, I am seeing that in this range, I am having the data of 1. Again, this data will be copied here, and this data will be maintained up to full clock period. That's why I am having up to here. Okay. Next, I am seeing the another edge here. So that time we have the data 0. That's why I copied 0. So register means edge triggered, whereas latch means level triggered, right? So the main difference here is the clock is as long as 1 or as long as 0, whatever the input changes, that the same is copied at the output side, then it is called latch. Register means it copy the data only at the rising edge or falling edge. Okay. So the register can be constructed by using two latches. I hope everyone clear this. Now we are going to see the difference between positive latch as well as negative latch. Positive latch means when my clock is 1, that time my output equal to input, right? When my clock is 1, that time my output is connected to input side. That means it is called the positive latch is in transparent mode. Transparent means whatever changes at the input side, it is transparent at the output side. Okay. Suppose when my clock is 0, what happen means my output is maintain the previous value. It won't copy from input side to output side when my clock is 0. So then we can say the latch is in hold mode, right? So always the latch having two modes, one is transparent mode, another one is hold mode. Positive latch means when my clock is 1, that time it will act as transparent. That means whatever changes at the input side that replicated at the output side means it is called transparent mode. Okay. When my clock is 0, that time the output is maintain the previous value or hold the previous value. That time the input data will not copy at the output side. So during clock is 0, we can say the latch is in hold mode. Similarly, negative latch means when my clock is 0, that time my output equal to input. That means when my clock is 0, as long as 0, whatever changes at the input, the same is replicated at the output side. That means when my clock is 0. Here when my clock is 1. Right? Then we can call it as the latch is in transparent mode. Similarly, when my clock is 1, what happens? That time my output equal to same. That is, it can hold the previous value. So that time we can call this latch is in hold mode. Similar to the positive latch, it is also having two modes. One is transparent, another one is hold mode. This timing diagram clearly shows that, see, my clock is 0 here, it is 1, 0, 1. Right? It is positive latch. It is positive latch. So this is my positive, that is clock is 1 during this period. So during this time, whatever changes at the input side, this is my input, right? Same is replicated at the output side, right? So during my clock is 1, whatever changes at the input side, the same is replicated here. That means the output follows the input, right? So I told you no, that latch is in transparent mode during when clock is 1. Okay, 0, clock is 0, that time what happened, we are going to see. See, my input is changes from keep on changes. The crisscross line indicates that the data is in unstable condition. That is keep on this changing. This double line is indicates that it's stable. Okay. This lines we could not able to predict whether the data is 0 or 1 because it is double line. If you have single line, we can say it is 0 or 1. But double line, we can say whether the data is stable or unstable. Okay. We don't need here whether the data is 0 or 1. That's not a problem. You can see here when my clock is 1, that time whatever changes the input, that is same as replicated at the output side. During my clock is 0, even though the input is changes, that is crisscross lines we have, right? Keep on the input data changes. Even though it is changes, that is not replicated here, right? That instead of that, This previous data is maintained same during this clock period. That's why it is called in this period, we can say the latch in hold mode. In this period, we can say the latch is in transparent mode. Similar here, negative latch, you can see here it is 1, it is 0, it is 1, 0. Right. So, negative latch in the sense what? When my clock is 0, during this period, whatever changes at the input, the same is replicated at the output side. Right. But during my clock is 1, during this time, whatever changes at the input side, it won't be copied at the output side. Instead of that, whatever I'm having at the last, the same will be replicated for the during the clock is 1. Okay. So, in this period, we can say the latch is in transparent mode. In this period, we can say the latch is in holding mode. Clear everybody? The difference between the latch as well as negative latch as well as positive latch. Next, we are going to see timing definitions. These are the timing metrics required for analyzing any sequential logic circuits. See, what are the things we are going to see here is what is setup time, what is hold time, what is clocked Q delay, right? So these are the things we are going to see here. See here, here we have the setup time, here we have the hold time. Okay, this is my input data, this is my output, right? So in the register we have input, output as well as clock. It depends upon the clock, the output will be connected to the input. That is, the register can act as transparent mode, another one is hold mode, right? It is a positive latch, so transparent means clock is 1 and hold mode is clock is 0, right? See here, my input data here it is stable. This double line indicates that it is stable. Here also it is stable. Here also it is stable, right? This point only it is changed. Okay, the input data is stable for some time before the clock is raises from 0 to 1, right? And also the input data stable after the clock is raised, right? See why this stable condition of data is required means for any register or latches, if you want to sample the data from input side to output side, this data must be stable for some period of time. Otherwise, the register will fail to sample the data from input to output side. This is the minimum requirement for any registers. The input data must be stable for certain amount of time in order to sample the data by the register from input side to output side, right? So how long time it has to be stable means before the rising of the clock, before the rising of this clock, the input data must be stable for certain time, that is called setup time. Similarly, after rising the clock, again the input data remains stable in order to sample the correct value. So that period is called as hold time. So it is setup time as well as hold time. Okay. Okay. So my input data has arrived at the register. Then this output you will get means even though if the data has arrived at the input, immediately we won't get the output, right? Immediately it won't copy at the output side. There will be some delay. That delay is called clocked Q delay, right? Even though the data is arrived here, we are not getting immediately this data changes here. Instead of that, the data is changes after some period, right? So this period is called as clocked Q delay. This clocked Q delay is nothing but the propagation delay of register. And one more thing you have to know, what is the propagation delay as well as contamination delay. We will see the next slide. See here, we have to know what is propagation delay and contamination delay. Propagation delay means it is the maximum delay, right? It is a maximum delay or delay due to the longest path. longest path, or it is called as critical path delay. That means, see, if you are designing any complex circuit from input to, if you are designing any complex circuit from input side to output side, we have many number of paths, So out of these all the paths, which path having longest, that will decides the maximum delay, that decides your maximum speed, right? So the path which having longest from input to output side, that is called critical path. That path providing your maximum speed of the circuit. Okay, simple example you can take this. In this we have some combinational logic. Okay, here we have the memory elements like flip-flops. How much time is required? Minimum how much time is required for this operation is, see here, actually the data arrived at the input side has to come at the output side, no? So it requires some propagation delay of the register of flip-flop, which is called clock to Q delay. Okay, this clock to Q delay, and this data will be arrived here, and that data must be stable for the during the setup time. That data must be stable in order to sample the correct value. Okay, so the input data. Okay, after arriving this data, you can see here the propagation delay. This is the combination logic circuit. It requires some delay to produce the output, right? After getting the input, it takes some time to get the output. That delay is called propagation delay of this logic, combination logic. Then this data again, it has to come to the register, and it has to be stable for the period of setup time, right? So during setup time, the input data must be stable. So total minimum time required for the correct operation is sum of the delay due to the register and propagation delay due to the combination logic circuit and setup time required for the register. So this is the minimum time required for this example circuit. Okay. What is the maximum speed? Maximum speed is 1 by T minimum, right? So this is the minimum time required, that means maximum frequency. The time period, if you are, it can increase, but it should be minimum, right? If you are increasing time, definitely the frequency will be reduced. So we can attain the maximum frequency when the minimum time, right? Okay, next we have to know what is hold time. See, hold time means actually the input data must be remain stable for the hold time period, right? In order to sample the correct value by the register. Okay. What does this time is? The hold time should be less than the contamination delay of register. Actually, this delay is nothing but the propagation delay. Okay. And this is contamination delay of register. Contamination means it is the minimum delay, and this is propagation delay means it is the maximum delay. Okay. Any circuit having minimum as well as maximum delay. Maximum delay is called clock to Q delay or propagation delay. Contamination delay means minimum delay. That means the delay due to the shortest path is minimum delay. Okay. Plus we have here contamination delay of logic. So the contamination delay of this logic and contamination delay of this flip-flop, if you are adding together, the hold time must be less than these two, right? Otherwise, what happens if the data is stable here for the hold period? That is, it is nth data is arrived here. It is in stable, or it is remain stable for the hold period. Okay. After the contamination delay of this flip-flop and contamination delay of this logic, the next data will arise here. Next data will be n plus 1. So this data must be stable for only the hold time. This hold time should be less than the total period. Otherwise, nth data as well as n plus 1 data will be collide to each other. So minimum, the hold requirement is the hold time should be less than the contamination delay of register plus contamination delay of logic. I hope you all understand this. This is the introduction about sequential logic circuit. Hereafter, we are going to see one by one topics. Thank you all.